I have a new recipe for you today. It's easy. You just have to follow 3 simple steps. First, you need to find one big star nearing the end of its life and heat it up until it explodes. That's called a supernova, the biggest and most powerful explosion we know about. It could take a while, maybe around 1 billion years, so you have to be patient. Step 2. As the core of this star is falling apart, stir all these electrons and protons until you mix them and turn them into a very dense soup. It's going to be hard, but you can't stop stirring. Toss in some gravity and apply as much as you think you need. So now you have some nice neutron stew. Crumple it to get an airtight sphere, approximately the size of Toronto. Cover the sphere with a crystalline crust, and it's almost done. Now you only need to serve it at about 1.08 million degrees Fahrenheit. This was a recipe for nuclear pasta. It's material that's 10 billion times stronger than steel. Talk about al dente, huh? No one can create something like that in a laboratory to really check how heavy and strong this material is. But computer simulations have shown it. Nuclear pasta could be one of the strongest materials in the universe in general. Neutrons inside the star are packed really densely, and the closer you get to the center, the denser it becomes. Neutrons get squeezed together and squished until they completely deform. Density there is more than 100 trillion times greater than the density of water. And the gravity is extremely strong too. On average, it's 200 billion times more powerful than the gravity on our planet. These crazy shapes that we call nuclear pasta are probably present only inside neutron stars. Their strong gravitational forces make their outer layers freeze solid, so they turn into a crust. But the insides are a liquid core. And there's also a fun party happening beneath the crust. Strong forces roil between the protons and neutrons and pull and push them in different ways. That means you can see all kinds of shapes below the surface. And scientists believe these shapes look a bit like pasta. For example, gnocchi and lasagna. These crazy shapes that we call nuclear pasta are probably present only inside neutron stars. It's incredibly strong, mostly because of its density. It's harder to break a coffee table than a cracker, right? How strong a material is going to be depends on its internal structure and how its atoms fit together. That's why some materials, such as chalk, are relatively weak because of all those holes. Diamonds are really strong since their atoms are well organized. Let's say you have a really massive star, like 8 times the mass of our sun. Bam! It collapses under the power of its own gravity. What's interesting is that a giant star can live for millions of years, but it can collapse within less than a second. And as a result, you get the whole mass of this giant star, but in a very compact core that's around 12 miles across. It would be like squishing the mass of 1.3 million Earths into one average American city. These are extreme conditions, and to be able to exist in such conditions, all matter inside a neutron star becomes way heavier than it would be in any other place in the universe. It's like having a single sugar cube that weighs over 1 billion tons, which is approximately the weight of Mount Everest. Neutron stars are also very hot. The temperature on their surface can go up to 1.8 million degrees Fahrenheit. For comparison, it's about 180 times hotter than the surface of our sun. And there are around 100 million neutron stars in our galaxy. We can spot them when they're relatively young. When they're not, they rotate really slowly. And they're also cold, which makes it hard to detect them. Neutrinos are very small particles that have almost no mass and travel at almost light speed. In only a couple of seconds after a star starts turning into a neutron star, the energy in neutrinos is the same as the total amount of light emitted by all of the stars we know about. Yeah, that's a lot. Listen up to this cool theory. If there was life on neutron stars, it could be 2-dimensional. Like in all those PC games that were popular in the 90s. Neutron stars are objects with some of the most powerful magnetic fields and gravity in the entire universe. The gravity is so incredibly strong there that it would probably flatten almost anything that ends up on the star's surface. Even the atmosphere would be different. Our home planet has an atmosphere that goes hundreds of miles into the sky. And since the gravitational force on a neutron star is so extreme, an atmosphere there could stretch for less than 1 foot. The fastest spinning neutron star that we know about rotates nearly 700 times in a second. And most of the neutron stars are probably pulsars, or they were at one point. A pulsar is a star that spins really fast, and while doing that, it spits out beams of radio waves. On Earth, it looks as if a giant lighthouse illuminates us. Because of their powerful fields, neutron stars can be dangerous for us too. If one got into our solar system, it would get chaotic. It could throw planets out of their orbits. If it got close enough to our planet, it could raise tides that would rip Earth apart. And what would be even more dangerous for us would be radiation generated by its magnetic field. Luckily, neutron stars are far away. The closest one is around 500 light-years away. There was an interesting case where scientists studied 2 neutron stars producing strong gravitational waves. 2 different stars here went through supernova explosions and left 2 extremely dense cores, neutron stars, behind. Scientists assumed these stars were going to merge, but they did something else instead. They were so close to each other that gravity pulled them together. They merged and created a black hole with one of the greatest mass we've ever found. Black holes and neutron stars have something in common. They both appear after stars finish existing, but black holes form when bigger stars explode. They're both extremely dense. You already know that not even light can escape a black hole because of its extreme gravity. Since they form in a similar way, some experts even say that neutron stars are failed black holes. Black holes are space objects that can create huge amounts of energy, although they don't produce any. But when 2 of them collide, there's more energy than all of the stars in the universe produce together. Black holes emit it in the form of gravitational waves. Most galaxies have one supermassive black hole in their center. Some of them are active, which means they shoot jets of different materials out of their centers. But most of them are quiet, sort of hibernating and waiting for some space object to come closer to feed on, like some hungry predator lurking in the darkness. So if you dropped something, let's say your keys, into a black hole, it would pull it inside before you even realize what's happening. Its extreme gravitational pull actually warps up space and slows down time. It would tug the keys closer and closer. After a while, they would go through an accretion disk surrounding the hole. This disk consists of space materials like gases, dust, and even rocks that circle inward around something we call the event horizon, which is basically the point of no return. Once your keys got inside, there's no chance you would get them back. They would probably end up being super stretched, or as science says it, spaghettified. A lot of things today are about food. I'm really getting hungry here. At the center of the black hole, there's a tiny point with enormous mass where density and gravity become infinite. It means time and space are different there than on Earth, kind of distorted. At least, that's what we can assume.